Welcome to Math TV with Professor V. It's Thursday, December 29th, 2022, and here is the integral of the day. We have an indefinite integral, 1 over x squared times the square root of x squared plus 4 dx. Now, if you want to go ahead, pause the video and give this one a try on your own, feel free. Otherwise, I'm just going to jump right into it. And looking at the integrand, right away my brain jumps to thinking, oh, it's time to use a trigonometric substitution. And which substitution do we use? Well, based on the fact that we have x squared plus 4 plus a constant, it's time to use tangent. So I'm going to go ahead and let x equal 2 tangent theta. If you're rusty on your trig sub, it's all good. I have plenty of video lectures. They're linked in the description box. And remember, we restrict theta to be between negative pi over 2 and pi over 2 when we make this substitution. You don't have to write that out, but just keep it in mind. And then that would mean dx is equal to 2 secant squared theta d theta. So now we're ready. We can rewrite our entire integral in terms of thetas instead of x. So we have 1 over x squared is going to be 2 tan theta quantity squared. So it's going to become 4 tan squared theta. Then I have square root, instead of x squared plus 4, that's going to be 4 tan squared theta plus 4. And then my cute little dx becomes 2 secant squared theta d theta. All right. Now, call the cleanup crew. We have some work to do. Particularly, I want you to focus your attention right here. 4 tan squared theta plus 4. Off to the side, let's work on that. I'm going to factor out the 4, and then I have tan squared theta plus 1. And hopefully you recognize, that's 4 secant squared theta. And this is all underneath the radical in our integral, which is perfect for us. And then this becomes 2. Now be careful, it's technically absolute value of secant theta. But like I mentioned in the very beginning of the video, we restrict theta to be between negative pi over 2 and pi over 2. Quadrants 1 and 4. Secant is positive there, so I don't need to worry about the absolute value. I don't write out the absolute value every time I do these. I just wanted to be thorough and precise for you lovely people. So there it is. And then now what that means for us is I can replace all of this, that rad 4 tan squared theta plus 4 in the denominator with just a 2 secant theta. Okay, very good. So now we have here integral. In the denominator, I'll clean up in just a second. So 4 tan squared theta, 2 secant theta, and then in the numerator we have 2 secant squared theta d theta. Do you see how that's all coming together so lovely? Okay, now let's see here. The 2 cancels. Not only that, this entire secant theta is gone, as is one of the secant thetas in the numerator. Take your constants outside. So I'm going to write 1/4. And then in the numerator, we've got secant theta over tan squared theta d theta. And, you know, I'm looking at this. There's not an obvious u substitution to make. No. How I wish it was tan theta and the... No, actually, I don't wish that. Okay, never mind. So when you're kind of at this point where things aren't looking lovely, just go back to sines and cosines. It honestly just helps you kind of recenter yourself, get your bearings, and usually they're easier to work with. So I'm going to rewrite everything now. We have 1/4 integral. Secant theta is 1 over cosine theta. And then since I have tangent squared in the denominator, then that's cosine squared theta over sine squared theta. Yes, yes. Okay, and then we can cancel a cosine. I hope that was satisfying for you. I liked it. And let's see where we are now. Is life any better? 1/4 integral cosine theta over sine squared theta d theta. Yes. Oh, I'm so happy. We can make a u substitution. I basically want cosine theta d theta to be my, excuse me, du, which means u would need to be sine theta, not sine squared. Oh no, that'll make life messy. So just let u equal sine theta, and then du is going to be cosine theta d theta, and watch the loveliness unfold. So we've got 1/4 integral. This is the kidney bean. I'm going to replace it with du, love it, over sine squared theta. That's u squared now, isn't it? Okay. And voila. Just rewrite your integrand now. U to the -2nd du. You should be able to antidifferentiate this. Leave the 1/4. Add 1 to the exponent. Divide by the new exponent. So it's going to be negative u to the -1st plus c. Okay, things are looking good. So this is negative 1 over 4u plus c. What was u? Right here. U was sine theta. So this is negative 1 over 4 sine theta plus c, which honestly we should rewrite as negative 1/4 cosecant theta plus c. All right? But we are not done, because remember, initially we made a substitution. We let x equal 2 tangent theta, and I have to write my final answer in terms of x, not theta, right? We went to trig land as a detour in order to help us evaluate the integral, but we can't stay there. It's time to come out of trig land. So we're going to make a triangle. X over 2 equals tan theta. Here we go. Here's my theta. Tangent of theta is x over 2, so that means opposite over adjacent, x over 2. The hypotenuse is going to be rad x squared plus 4. Thank you, Pythagoras. And then now we can go ahead and figure out what cosecant of theta is. Cosecant of theta, that's the reciprocal of sine, right? So sine is opposite over hypotenuse. Cosecant's going to be hypotenuse over opposite. Hypotenuse is rad x squared plus 4. Opposite is x. So that's the ratio we need. Rad x squared plus 4 over x plus c. Do you leave your answer like that? No, it's so ugly. You know, have some respect for your work and mathematical aesthetics, please. So put negative rad x squared plus 4. Even that 2 was too ugly to live with. There we go. Over 4x. See how nice it looks now? Plus c. Now we can box this and move on with our lives. So there you go. I hope you enjoyed the integral of the day. I know I haven't uploaded in a while. I took a little break. I was on a trip with my husband and parents. It was lovely, but we're back now. I'll record here and there and then get some stuff ready for the new semester in the meantime. I hope everyone's doing well, enjoying the extra time off that most of us have, being with family or whoever we care to spend our additional time with. So hope you guys enjoyed the video. Give it a thumbs up and check out the rest of my lecture videos on my YouTube channel. I have so many, especially Calc 1, Calc 2, Calc 3. I have every lecture video for the entire course, the whole entire semester. And I'm working on adding to my linear algebra and differential equations video lecture playlists as well. Subscribe if you haven't already. If you want to see what other shenanigans I'm up to, you can follow me on TikTok and Instagram at MathTV with Professor V. I'll talk to you guys soon. Bye.